Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Yeah, today we would like to have a lecture about microhidro development in Indonesia. This lecture is actually special for the student who took concentration microhidro, but for you, for the other student who took waste management and also industrial, small and medium enterprise can be also a student here. Okay, we would like to start. Yeah, microhidro development, Yogyakarta Special Region in Indonesia. Yeah. Okay, this is a potential of microhidro. You know, this is small irrigation channel. It's not small. It's about 2 cubic meter per second, and the head drop is about 2 meters. Yeah. This is a potential of microhidro, and you can find not only in that case, almost every region in Indonesia has microhidro, irrigation channel. Yeah, and every irrigation channel you can find drop, yeah, something like that. So that means you can imagine how many kilowatt you can produce electric from that kind of potential. Yeah. And almost 90% of our potential in irrigation channel is not used until now. Because of what? Not because of engineering, but because of engineering and also social problem, economic and sustainability problem. A lot of microhidro is installed, but not work. Economically not work, socially not work. Engineering is work. Yeah. So that is our problem. Okay. What is the background? You know that oil price increase rapidly now. Yeah, that means you will spend a lot of money for oil. Yeah. Fossil fuel. The demand of energy increase in accordance to autonomy process. You know, especially in Indonesia, the demand on energy increase rapidly because every region would like to have energy more and more. Time by time, year by year, increase significantly. We have to fulfill that demand. How to fulfill? You can also buy oil, fossil, yeah. But yeah, with the price very high price, then you cannot always buy it like that. You have to develop another resources like PLTMH, Pembangkit Listrik Tenaga, Mikrohidro, or Pembangkit Listrik Tenaga Air. You can improve small microhidro, also you can improve also middle hydro, also high head power plant. So the energy production is almost stagnation until now. It's not increased significantly. Energy distribution is also not developed well since geographical situation. Our situation in Indonesia make the distribution of energy is difficult. Yeah. And the other side, we have enormous on microhidro potential in Indonesia, resources. If you go here from here to in the north side, north direction or east or west direction, you will find river, and you can also improve microhidro from that river. Or in Java, for example, you have huge amount of irrigation channel, and you can just go through the irrigation channel. You can find every 1 kilometer drop. Technically, engineering, you can solve, you can build But the problem is not only how to build, but how to handle, how to manage after construction to get power and to use the power for economic activity. This is the big problem right now. You learn about microhydro is not only from engineering side, but you have to learn also from social side and economical side, and also from environmental side. Yeah. So, microhydro is one promoting generating renewable energy in Indonesia. One promoting generating renewable energy in Indonesia. Another land understand well. Germany understand that Indonesia has a huge amount of potential of hydropower. Japan know well about that. Australia know well about that. They want to go to Indonesia to work with us to develop that kind of microhydro or hydropower plant in Indonesia. Because renewable, no pollution from microhydro, from hydropower plant. The technology of microhydro special is easy to transfer by local people. So it's not too difficult to develop this technology. Even that you have to learn, not just doing, but you have to learn first and understand the limitation of this technology. But important thing that you can bring that knowledge to the people. This is the important thing. When the knowledge already by community, and the community understand well, and they can develop by themselves. So this is our goal. Our goal to learn microhydro. The energy can be used for small and medium enterprise. Let's say if you have microhydro and you try to make a kind of a small and medium enterprise around microhydro with a good planning, then I think you will find a kind of multiplier effect from your microhydro. Yeah, like what we have seen in Bantul, Imogiri. Yeah, the microhydro has multiplier effect because the people around microhydro use the energy for pabrik tempe, industry tempe, and in the daylight they use the microhydro to pump the water for swimming pool, village swimming pool, and also in the dry season they pump the water to the field, rice field. Then, if they can also then produce one more microhydro with, let's say, 1 kilowatt, 2 kilowatt, 3 kilowatt, they can make a kind of small and medium enterprise again and again. Yeah, this is in theory. The reality, you have to go there and working there until the whole system is working. Okay, and human resources in microhydro in Indonesia is enough and distributed over Indonesia. So people who understand about microhydro in Indonesia is already distributed. But where you have to learn. Yeah, you are the new generation. They will be also older and older, and you are the new generation. That means microhydro can be distributed very fast to all of island in Indonesia. Let's say in Irian Jaya in Papua, we have already more than 15 people understand about microhydro, our alumni here. In Kupang, we have also some people in East Nusa Tenggara. In West Nusa Tenggara in Lombok, we have also some people, there are 10 people who understand about microhydro and small and medium enterprise too. In Java, you have a lot of people understand about that, and a lot of people have already built about that. In Sumatra, Sulawesi, and Kalimantan. But the problem is not how to build, I have said to you, but how to maintain, how to arrange, how to make microhydro automatically produce energy, and the energy will be used for activities. Yeah. Institution and industries working in microhydro field is enough also. We have also institution, every district we have already institution who which take care about the development of microhydro, and we have also industry. Let's say in Medan we have 2-3 people who has industry for producing microhydro turbine, control unit, and so on. Yeah. You can find there Mr. Ivan and Pak working there. And if you go to Lampung, some people there. In Bandung, we know Pak Edi, Cianjuang, Hexa, a lot of people there. Here, we know Surya Dharma, our MST here, can also produce microhydro and build microhydro. If you go to Jawa Timur, you will find Pak Cipto. If you go to Sulawesi, you will find Pak Ligge, and so on. So, if you go to Papua, you will find Baru, I don't know the real name, but people who are working there, Suyatno, and so on. So, but compared to the geographical, Indonesian geographical, that human resources even already distribute all over island, but we need much more people who can build and can maintain the microhydro. Good. The concept on microhydro development is something like that. Yeah. Say, microhydro or hydropower plant produce energy for electric supply, of course. But for what then? For village enterprise. First for village enterprise. So, if you want to build microhydro, it's not stop in building microhydro and producing energy, and you say, for using the energy is not my business. No way. You have to make sure that the activity after microhydro construction is your work too. Your work as a system engineer student is not only how to produce electric, but how to use the electric until you produce something to sell and you get money for income for the microhydro, because microhydro need also maintenance, need also money for people who work on and so on, and need also money to build a new microhydro. Yeah, so the system like spiral, one microhydro in the beginning, in 2 years we'll have 2 microhydro, another 2 years you have 1, 2, 3, 4, 4 microhydro and so on. So then you will have much more microhydro. It will be happen if your microhydro produce electric and the electric used for the village enterprise. I think I have already talking to you about that. You can use the energy for several purposes, like milling unit like this, milling unit for chocolate, rice, peanut, tefu, tempeh, and so on. Yeah. So, or to veterinary, yeah, or agriculture production, another agriculture production, or you can use microhydro for drying unit, yeah, for ginger, for coffee, every purpose. Important is the energy should be used. Coffee, yeah, for example, garlic, onion, ginger, rice, chicken broth can be used also, and others. Another thing is for water supply. So, if you have a water problem in water, I think drinking water, you can use the irrigation channel for microhydro, and you can couple the microhydro turbine with pump, and you pump water from deep well, and you get water for water supply. Or you can also pump the water, irrigation water, from the low head to high head. So Why this is important, water supply? Because with pump, your microhydro energy is very effective because you can use 24 hours for pumping. But if you use for lighting, milling unit and so on, it's okay too, but it's not effective because you have to turn off, turn on, turn off, turn on. The energy which your producing energy will be sometimes used, sometimes not used. Yeah. Okay. And water supply, irrigation pump can be used also, or garment village, all the activities. And what is the very important thing that I want to explain you is about waste management here. So our concept is actually in one loop concept. We have energy, concentration microhydro to produce energy. Of course, you should not only learn about small microhydro. For starting, you can learn that. Then the other concentration is small and medium enterprise around here, here and here. So you can also learn about small and medium enterprise. Yeah. And the other topic, concentration, is waste management there. The waste management is also for you because the whole small and medium enterprise produce waste, solid waste and wastewater. Then you have to learn how to handle the waste. So our concentration, our system is actually already compact. We have energy, we have small enterprise, and we have also technology for waste management. Yeah. But you have to learn by yourself also marketing. Yeah. Accounting, because you need for that. Yeah. It is pity if you just build something and you cannot sell. It's not systemic thinking. If you build something, you have to sell. Don't say, let somebody else sell it. No, maybe somebody else don't want to sell your product. Or minimum, you have to find out people who can sell your product and you get money from them. You should not sell by yourself, but you have a system for selling the energy. Okay? Good. The use of microhydro energy electric can be in several types. For example, here in the very remote area for lighting, or this is the microhydro, and this is the turbine, yeah, and coupled direct with the rice mill, then you can produce rice mill. Yeah. The renewable energy development based community for increasing the living standard. This is the concept, yeah, the concept. One thing that you have to learn also how to realize the concept. Not only the concept itself. The concept is nice, but how to realize the concept is one very important thing. This is a systemic thinking, combination between the thinking world and living world. How to plan and how to implement. You should not satisfy with information that you get already, that you have already learned. It is not systemic thinking. You have to satisfy if you have already learned and you have already done. I have learned and I have done. And I have knowledge. Yeah. Learning, you get on the information. Yeah. Good. The other potential like that, for example, we have a lot of wheel. This is a wheel. Wheel in Indonesia, in Bahasa Indonesia is bendung. Yeah. And dam is bendungan. Yeah. Weir is bendung, something like that. You can see here, you still have water. 3 cubic meter per second, for example, very wide river. Even you have to think about the environment also, like you have to fulfill here with fish way, so the fish can also swim up and down. So even you have a weir, you still have ecosystem, fish ecosystem, yeah, with fish weed. But this is also potential microhydro that you can produce. For example, here 5 meter or 4 meter, for example, with 3 cubic meter per second. Then 5 times 315, you can produce about 75 kilowatt. We do not talking about megawatt. Megawatt is the huge amount, huge scale of microhydro, and for the student just a dream. But under 100 kilowatt for the student is not a dream. This is reality. You can produce, you can work with it. Yeah. Don't always think about the big thing. 2 mega, 3 mega, 6 megawatt, but you cannot do that. You can start with 10 kilowatt, 5 kilowatt, but you can do by yourself, and the people can understand. And then by the time you increase your ability from 10 kilowatt to 20 kilowatt, I can handle 20 kilowatt, I can build, I can also handle, I can use the energy. It's nice, yeah, for example, something like that. And then after 10 years, you say, no problem, I can build 1 megawatt. Yeah. After finish from the microsatanic system here, you say, I can handle 1 kilowatt now, 1 megawatt. No. This is not real. This is only 3. Yeah. In reality, you can build 10 kilowatt. Okay, it is enough. It's nice. Yeah. You from Cambodia, if you go home, you say to your government, I can build 5 kilowatt. And the government might say, it's too small, 5 kilowatt, no problem. I will show you how to build 5 kilowatt. Next year, I will 10 kilowatt. In 5 years, I can 50 kilowatt. In 10 years, maybe I can 200 kilowatt or 1 megawatt. It is realistic. Yeah. In my student time was, I learned about 100 megawatt. I learned how to build a hydropower plant 100 megawatt. But in the reality, I cannot do. It's impossible to make that. I can show people doing, yeah, but I cannot make it. Yeah. So we have to start from small thing. Of course, you can also, as a member of the group who develop 1 megawatt, no problem. But if you want to develop by yourself, you can say, okay, I can make 10 kilowatt. It is my business. I can do by myself. Yeah. Good. Microhydro potential in one region, like for example, Yogyakarta, you can see this is 2006. We have a lot of microhydro here, for example, here, there, here. One small region, yeah. And we have also a lot of another region, like here, yeah. This is water, and this is also water. Why don't we use that water? This water is very clear, and you can use just open intake and let the water flows to the intake, and then you can get energy. Yeah. Producing energy. But yeah, this is river. Yeah, river flowing down here, and here the weir. Yeah, look at this. We can open here and make it microhydro here, yeah, and the river can be closed again back here, and you have produced microhydro there, yeah, like this. You can see here. You can also make here the intakes much more bigger intakes, and you let the water flows here, and you give it back here. In here, you can build microhydro. Yeah. So like this here, this is a sediment trap channel, and then here you turbine, and then here you have a channel going to the turbine. The turbine will be running because the head here and here is different. The head difference can be, for example, 10 meters or 6 meters. So the turbine here will run because of the head, and then here you have generator. The generator will also be run, and then you have electric. It's very simple. The water comes down here because of water head. The turbine propeller is running or was run, and then the generator produces electric. This is a simple concept of microhydro. That way, this is also easy to develop. And here in several where we have a lot of potential, like for example here in Gledongan, they had a 5 meter. The discharge is 300 liters per second, small discharge. Effective efficiency we have only 0.6. We can increase to 0.75, but normally 0.6 is already good. Yeah. And we have energy 8 kilowatt only. Yeah. Yearly we have 67.5. 6.6 kilowatt is not. This is okay. It's not a small amount of energy because 24 hours. Yeah. So you can use for small and medium enterprise with each kilowatt. And here, scarcely, you have 14 kilowatt. Of course, you can also produce 1 megawatt, but maybe it's not your skill. 10 kilowatt, 15 kilowatt is your skill. Good. If we want to calculate, this is not too difficult. Yeah, we have 0.6 efficiency. We have 8.8 kilowatt the energy producing, and 11 month, because 1 month for overhaul and for maintenance, you have 67.5 kilowatt hours, 1000 kilowatt hours, and we have now is 1056 per kilowatt hours, 1056 rupiahs. Income per years you have 71 million rupiahs already. Using for operational, you need one person to operate about 1 million to times 12, where you have to spend 12 million. And then in maintenance, you have 6 million, about 6 million. You have income per year 53 million rupiahs. If you sell that energy to PLN. Of course, the problem is to sell, how to sell. The PLN would like to have a good quality of energy. What is good quality? Good quality is the frequency 50 Hz, for example, with 220 volt, for example. Regular, that means PLN don't want to have 1 hour's energy and the other hours you have no produce the energy, the stable energy. So we have to do that, to convince that our energy production is stable, good quality, then we can sell to PLN. Selling to PLN, if you can sell to PLN is the best. You should not think another thing. You just sell to PLN, you get money. And how about the money? The money is yours. If the community around the PLTMH also included the project, you have to share with the community. The community can use money for another purpose, and so on and so on. And then we make a recommendation, for example, because the scarcely beer we have 15, potential 1, and the smallest potential priority 5. But actually you can take the priorities depend on. For example, the 11 kilowatt is already is near to the community. The community ready to share. Yeah. The community need the electric, maybe even on the 8 kilowatt. This is the priority. Very high, for example, 15 or even 100 kilowatt, but the community do not need that. And nobody care about that. It's far away from the community. It's too dangerous and so on. This is not the priority. Priority will be recommended if engineering possible, social also possible, economic also possible, and environment is possible. Yeah. Or in engineering possible, social, adaptable, people understand, can do that. Economic, accountable and feasible, and environment sustainable. Not that the waters come only this year, next year we don't know whether the water flows or not flows. Yeah? So, I can show you also another potential in another place here, like in Semawo here. Some of you maybe has already seen, yeah, this potential. This is huge amount of potential in Semawo. This is irrigation channel. You see, this is without water, this is with water. The head different is 10 meter. You have to visit there. Yeah. I will give you task to visit so that you understand. Huge amount of water. Semawo is Kulon Progo. They are not far from here, only 1 hour. Using motorcycle, then you can find that. And about 10 meters, and the discharge about 5-6 cubic meter per second. 5-6 cubic meter per second. A huge amount of potential. Of course, it's not until 1 megawatt. Yeah. Yeah. So another location in Kedung Rong here. Look, these two potential, Kedung Rong 1 and the other Kedung Rong, is huge amount. The discharge is about 3 cubic meter per second. The head about 5 meters. Yeah. 5 meters and 3 meters. You can imagine a huge amount of. Let's say we try to see. The head is about 6 meters. 6 meters. Discharge about 3 cubic meter per second or 3,000 liter per second. The energy is about 90 kilowatt. 90 kilowatt. And every year we have only calculated 11 months. So we have 689 kilowatt hours, 1,000 kilowatt hours. If you want to sell to PLN with 1,056 rupiah per kilowatt hours, your income per year is 727 million rupiah per year. And this irrigation channel, this potential is already 50 years not used. That means you lost your money 727 million times 50 years already. You can imagine. The operational, you can use one person to operate, and also with maintenance 6 million. Then you have about 700 million rupiah per year. 700 million rupiah. In the village, it's huge amount of money. Maybe in New York, it's not too much money, but in a small village, you can imagine. If you can sell and give it the money to the people to develop their economic activity, you can imagine it's very huge amount. And look this, we try to have infestation. We propose the capital $2,500 US per kilowatt. Yeah. So you need 225,000 US dollar per kilowatt. And if we have now 1 US dollar is 9,100 rupiahs, you have to have money 2 billion rupiahs. Yeah. So if you should spend money 2 billion rupiahs, you have already 709 million rupiahs. Your money will back in 2.89 years or 3 years. 3 years your money will back, and the other 22 years it is your money. Yeah, or the money of the district region. Of course, from the calculation is easy, but how to implement is another question. You cannot say, oh, we can invite people from outside, from Germany or from Japan, or from another country coming here to develop that. If you do that, that means forever you cannot. You have to say, we have to do by ourselves, our hand, because we have a kind of responsibility to deliver our knowledge to the young generation. The knowledge can be delivered if we can do. If we cannot do, we cannot deliver. Yeah. Information is not knowledge. The knowledge is information, time, experience, time, attitude. If you have attitude to deliver knowledge to the new generation, that means you have knowledge. If you have no attitude to deliver your knowledge, that means you have no knowledge, you have no only information. Yeah. So, good. This is the other location in Kedung Rong 2. Yeah, Kedung Rong 2. Look at this here, from here. Huge amount of water flowing down. 6 meter water fall with about 3 cubic meter per second. 3 cubic meter per second. Yeah. If you go there, you can see, it's very nice. If we have money, we can develop it. Yeah, but it's not only develop, we have to use. Bring back. Sorry. We have to go back a little bit. Here. Again. So, let's be careful. Now, it's not only 6 but 7 meters they have. And the discharge is almost same because this is one irrigation channel. After drop 1 and drop 2. Maybe in the other, and if you go down again, you will find again. Yeah, the water drop there. Yeah. If you go upstream, maybe you can find again. Yeah. So the energy is 100 kilowatt. Nice, 100 kilowatt. Not 1 mega. 100 is, for me, is a big energy. Good. Then you have 765.6 kilowatt hours with 1,056 rupiahs. Yeah, you have 800 million per year. And your operational 12 and 6, you have about 790 million per year. Almost 1 million per year. Yeah, let's say 700 is okay. The 90 million you can use for another thing. So, with this kind, you in 2.8 years, only 3 years, you can pay back the money from bank or from other resources. If the money from government, you cannot not say, oh, the money is from government, we bill and finish. No, you have to think about, even the money is from government, spending to the people. You have all these things. In 3 years, we have to collect money. Same with our capital. The money can be used for development again. How to get that? This is important. You have to sell to PLN if you want. Yeah. And the money can be used for economic growth and so on. as long as in that region has already electric distribution from PLN. If the people do not have electric from PLN, then you can use directly distribute to the people around there. Yeah. Good. Another location is in Desa Jurang. Yeah. Look like very small. This is person here, and here is the. You can see here it's about 6 or 9 meter. Yeah. They had different here. Desa Jurang. We can build that. Yeah. Calculate 3.15. Yeah. This price is nice. Yeah. This price is good. Yeah. If the oil price always increase, that means the energy microhydro better and better. Yeah. Good. How about in a very arid area, for example, here in Gunung Kidul? Yeah. Gunung Kidul. Yeah. We see that Gunung Kidul is stone area. Yeah. Not too much water there, but I try to find the resources of microhydro. You see here, very small amount of water flowing down here until here. And this is a potential. Even only, for example, 20 liter per second. But if the head you have 100, yeah. So that means it's same with very huge amount of water, but they have only 1 meter, 100. So then we have much more important construction. In Gunung Kidul, we have also potential underground river. Underground river. Have you ever seen underground river? Not yet. You have to see. I will give you task to go down. Yeah, I give a sign, give it to you, and you can go down, and you will see what kind of. This is the project created by district government and German Council University and another field, and Batam and also Gajah Mada University, also MST, I'm there. So this project called Microhydro Construction Underground River and Karst Area Gunung Kidul, Yogyakarta Special Region, Indonesia. This is the river, underground river, about 100 meter under earth surface. This is the earth surface where you cannot find water. Every rainfall coming down here and flows down. Yeah, here, and here you see stalactite and stalagmite. This is stalactite, and down here you have stalagmite, and underground here you have water. The water collected here and flows down. And here we build a barrage, or we stop the water there. And the water in here's a river, pipe river like that, underground. And in the very small area we build a barrage, and then the water cannot flows down because there is barrage. The water will increase, and we have a head difference. The head difference is about 15 meters. 15 meters. More than 15 we don't want, because the structure of the karst area is very porous. If you put the head difference more than 15, we don't know whether the karst area can hold the water or not. Yeah. Because we have experience in Hungary. In Hungary, people try to have head difference 75 meters, and suddenly the whole river is broken. 75 is very high. Very high. 75 meters. Now we have only 15. So it's already done well. And you see here, this is a microhydro. We have 1, 2, 3, 4 microhydro. The water flows down here, and here we have turbine. The turbine coupled direct with pump. Here's the pump. This mechanics, not electric. The turbine is not used for producing electricity, but the mechanical torsion coupled with pump, and the pump the water. So then we get water here. Yeah. So every turbine is about 20 liter per second. So we have about 80 liter per second. 80 liter per second means we can serve people 80,000 people. 1 liter per second for 1,000 people. 80,000 people. 80,000 people can be served with by 80 liter per second. Yeah, it's well done. Noise work is good. Yeah, and we would like to have one more in another place, because you know river. If you go down to the earth and you find river, you can stop here, and afterwards you go down again and you can stop there, and you can go down and stop there again. Yeah. Theoretically, it's unlimited place. Every 1 kilometer you can make it again, make it again, and make it. Theoretically. Practically, another question. Yeah. Practically, you have to go down there to make analysis, to make a research, to measure the discharge, to measure the possibility, to drop down, to make a hole, and so on. Yeah. So this is the thing that you understand well. Between theory and practice is quite different. You have to understand that. What I want from you is that you not only stay in the theoretical thing. Theoretical thing is easy. You can learn in one night and understand. But practical, you have to go down to the real situation and work on. And then you have information from books or from lecture, and you have also opportunity to work on them. Yeah. So then you combine between theory, between information and practical experience, then you have knowledge. Yeah. Okay. So this is the Ribin, Worbosari, Kabupaten Gunung Kidul. Head is 15 meters. Yeah. Discharge is 1,000 until 2,000 liter per second, or 1 cubic meter to 2 cubic meter per liter per second. If you calculate, we have 350 kilowatt only. 350 kilowatt. Yeah. And if we can pump the water 80 liter per second, with the height is 250 meters. Yeah, from the river underground, you pump 100 meter plus 100 meter plus 50 meters, and from that you can distribute to the people who need water. Yeah. If you do that with a class, you can imagine how many pahala you will get. Yeah. You will get a lot of pahala, and you will fly to the event with us together. Yeah. But not now, yeah, because no, we have to do something. Okay, this is the. Even you have only very small spring. If you go to the hilly area, sometimes you find very small spring there. You can root trace the small spring, go down and go down. You can measure with theodolite or with just water pass, and then you can find the head different. You can make a pipe there and micro it. Maybe you can get only 1 kilowatt, but no problem. 1 kilowatt is already 20 balloon, yeah? Bulan, 20 bulan with 50. Yeah? 50 means you can divide it also 50 into a small bulan, 5 small bulan. Then you can about 20 household. Yeah. So don't worry about that. Look at this here. Head only 2, 15 liter per second. You have 1.7 kilowatt here. Yeah. So here 10 meter. That was 10 meter. with 10. This is very small amount of water. But the head is 10 meter, only 10 meter per second. You have 1.8 kilowatt. Yeah. 1.8 is usable 24 hours. Here 3 meters, 18, we have 3.5. Yeah. Not 3, 30. I think it's 30. 3.5 kilowatt. This is also 30. That was 30, and this is also 30. Then you have also 3. Good. So here we have 20 water head in Bleberan, Playan, Gunung Kidul. We have 20 meters. But the discharge only 35 liter per second. Only 35, just very small creek. Yeah. But the head is 20 meters. This is nice because it is cheaper than you have 1 cubic meter discharge, but only 1-2 meter water head. You need big turbine. Yeah. But if you have very high head, different and very small discharge, you only need, for example, only 20 centimeter like here turbine. But they can run the producing energy is the same with very big. Yeah. So the higher difference, the better in the microhydro, the cheaper. Yeah. The less head difference, the expensive. Okay. This is in Pojong Gunung Kidul. We have also 1 point. Yeah. This is in Spring in Pojong. Yeah. We have also in Banyuroto 1.4. This again 1.4. We have 2 meter 20 liter per second. Yeah. Okay. This is Spring, and this is also a microhydro in Yogyakarta. We already implement. I will show you here the implementation of microhydro. Maybe my lecture will be in 10 minutes finish. Yeah. For example, project in Minggir Sleman DI, discharge intake 0.85 cubic meter per second or 850 liter per second, and head we have only 2 meters. The output we have 10 kilowatt. Look at this here. Yeah, this is the irrigation channel in Minggir. Something like that. So we have place here for building microhydro. Powerhouse here we have place, and this is the channel. Going down here, the channel. Yeah. Look. Yeah. This is the channel. I show you, this is upstream, this is downstream. It's already about 40 years this irrigation channel not used for energy electric. The head difference here about 2 meters. Yeah. So then we try to build powerhouse there. Yeah, here part powerhouse rumah Pembangkit. Yeah, this is irrigation channel. Yeah, this is release chamber, release channel. Again, yeah, here we can say sediment track area here before we are going to the channel. Here the channel is not penstock but channel, flowing the channel to the turbine. Yeah. This is the irrigation here. We make here powerhouse here. This is channel going to the powerhouse, and the turbine will be here, and the water flows again to the irrigation channel. So the water should not flows outside from the irrigation channel. You have to bring the water back to the irrigation channel, otherwise the farmers will be angry to you, because they need water. Yeah. You just take the energy, not take the water. The volume of the water should be same before and after microhydro. Yeah. So here is the chamber for turbine chamber here. This is the release water, release channel going to the irrigation channel. Yeah. Again here. Here is the intake from the irrigation channel to the sediment trap chamber, and going to the orbite in there. Yeah. So this is the gate. Yeah. Then you can arrange how many discharge you want, how much water you want to, how much water you want, how many cubic meter you want to release there. So this is enough. This is from water from irrigation channel going down here, the sediment trap here, and then coming to the orbite channel. Yeah. Gate again. Yeah. Okay. So this is channel coming down there. It's not banked out, but this is orbite. This is the turbine holes. You will pull the turbine on the hole there, so the water flows to the hole and coming down to the irrigation channel. So you use open plant turbine here. Open plant turbine. The open plant will run 2 open plant turbine, and we couple the energy into one generator. The generator 1, but the turbine is 2. So the generator will be run by 2 turbines. Yeah. This is best good. Yeah. So then we minimize the generator. This is not turbine but turbine hole. Yeah. The turbine will be plugged on the holes. So the turbine will run. The water flows down to coming out, flowing out to the irrigation channel. Yeah. So look at this. Here is the intake coming here. You see here the channel coming here, and you can see from here, this is the floor for everything. You can go inside to the panel here, then you will find here, in this place is turbine. Yeah, will be. You can see here, this is a turbine chamber here, and the water flows there. Okay. Again, and here is, you know, the powerhouse is very nice. Yeah. Look from several sides. It's nice powerhouse. You can use for apartment maybe if you want. Okay. Again. Yeah. So this is the channel. And you have to have a grid here to avoid the waste garbage. Yeah, a lot of experience you have to have how to not allow the waste coming to the intake. The waste should flow down, and the water coming to the intake. Yeah, intake here coming down there, here from here go here to the powerhouse, and here the water. We build also here a gate, so we can stop the water here. The water only flows. Yeah. Okay. Good. Yeah. This is 3, 4. This is the. So here we can take the grid and pull down again. Yeah. Press right. This is the gate. Here we have also small here, spillway here, in order to always have the same level of water. The water level should stable, not because if you have your water level always something like that, then you have your frequency and your voltage will be also, and the PLN don't want to buy that kind of electric. So that way you have to have spillway here to make sure that your water level is always there. More than that, close down. Yeah. So spillway here going down and come back again to the front. Okay. Yeah. We try to invite people around there to work on with us. This is a kind of community development together. Yeah. Working here. Yeah. Yeah, look, it's very nice. The water still flow here. It's not used. We can close this gate here. Close the gate. The water flows there and going there here. Almost finished. Almost finished again and again. Voltage, electric watt 10 kilowatt with voltage 220 volt. Yeah. So that was our first project that we make in Bagian and running. Yeah. But the problem is we have already tried 2 years to sell the electricity, but not finished yet until now. So sometimes this microhidro is broken because the turbine is in the water, start to corrosion. Yeah. The propeller cannot move. Every years we have to pull out and repair and pull down again, but nobody used that. Yeah. The problem is the utilization after construction, not to build. To build, yeah, ready, but to use is another question. Okay, any question from you? For that, okay. Do you have a question? Yes. You? You can ask me in Bahasa Indonesia if you want, no problem. Yeah. Do you have a question? Not yet? Okay, I think it's enough our lecture for today. I hope that you, for the first lecture, you understand well about microhidro and the problem. And then the task of you is, one group of you going to that location, Minggir, just to make scan everything, and next week we will discuss about it. Yeah, I think so. You are 7. It's only one group. Yeah, you can call our people there. I will give you the number, and then you go there, going inside and see, make a photos and make a presentation. Next week we will discuss about it. And somebody has already seen a little bit about the channel and so on, and we will discuss about the problem after reconstruction. Maybe good, maybe not. Yeah. Okay, thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang.